Experiment 10. Verification of Beer-Lambert's law. Spectroscopy deals with the production, measurement and interpretation of spectra arising from the interaction of electromagnetic radiation with matter. There are many different spectroscopic methods available for solving a wide range of analytical problems. The determination of concentration of analyte in the given sample solution is based on the measurement of the amount of light absorbed from a reference beam as it passes through the sample solution. In actual practice, the solution to be analyzed is contained in an absorption cell and placed in the path of radiation of a selected wavelength. The amount of radiation passing through the sample is then measured relative to a reference sample. The relative amount of light passing through the sample is then used to estimate the analyte concentration. The relationship between the absorbance of solution and the concentration of the absorbing species is known as Beer's law. Lambert's law. When a ray of monochromatic light passes through an absorbing medium, its density decreases exponentially as the length of the absorbing medium increases. Beer's law. When a ray of monochromatic light passes through an absorbing medium, its intensity decreases exponentially as the concentration of the absorbing medium increases. These two laws are confined together in the Beer-Lambert law. The ratio of intensity is known as the transmittance and is usually expressed as percentage. Taking logarithms, the expression log 10 I/O upon I is known as the extension E or absorbance. The extension is sometimes referred to as the optical density, but this name is no longer recommended. Therefore, E equals to KCl. Principle: all the colored substances absorb light under visible wavelength. The absorption of light takes place at different wavelength depending on the color of the substance. The extent of the absorption, which is termed as optical density, is directly proportional to the concentration of the solute in the solution at lower concentration. Procedure: prepare 0.1 normal K2CrO4 in 0.1 normal KOH. Pipette out 0.5, 1, 1.5, 2.0, 2.5 and 3.0 ml solution in each of the 6 test tubes and make the volume to 10 ml. Mix thoroughly by inverting the test tube upside down, converting with the thumb or stopper. Adjust the spectrometer to 100% transmittance with distilled water in the cuvette and 0 by inserting black rod instead of the cuvette. Take optical density of each solution at 490 nanometer wavelength. Draw a graph optical density versus concentration. A straight line verifies Lambert-Beer's law. Observation. Result. The absorbance is directly proportional to the concentration in dilute solution.